Hello everyone. In this video, we are going to discuss interpretation of temperature and the derivation of expression the average kinetic energy is equal to 3 by 2 kT, where K is Boltzmann constant and the capital D is temperature in Kelvin. You derive this relation, we know that as the pressure of gas P is equal to 2N divided by 3V average kinetic energy. If you don't know this result, you should check our playlist to derive the relation the pressure of a gas in a container, in which we derive that the pressure at any point in a container P is equal to 2N divided by 3V. N are the number of molecules and capital V are the volume and average kinetic energy. If we calculate the product of pressure and volume from this equation, we will get the pressure P multiplied by V will be equal to 2N divided by 3 and average kinetic energy. It's our first equation. And the secondly, we have to know that the ideal gas equation PV is equal to nRT, and here the small n is different than capital N. Capital N is the number of molecules. Here the capital N is number of molecules, but the small n is number of moles. Then we can write this equation. The PV is equal to the small n number of moles will be equal to the mass divided by molar mass, or here we can write the small n number of moles is equal to the number of molecules divided by Avogadro number, or the number of moles is also equal to the mass of a gas, total mass of a gas, and divided by the molar mass, means mass of a 1 mole. Then we can get the number of moles. We can get number of moles by two relations: the mass divided by molar mass, or the number of molecules divided by Avogadro number. Here we can write this equation: PV is equal to n. Small n is number of molecules divided by Avogadro number, R, which is ideal gas constant, and capital T. From this equation, we can get the PV is equal to capital N R divided by NA multiply by capital T. Here R divided by Na is another constant. R is ideal gas constant, and Na the Avogadro number, where Na is equal to 6.02 into 10 raised to power 23 atoms or molecules. Here we are considering the molecules. Then R divided by Na, as R is 8.314, the ideal gas constant, and divide by Na, the number of Avogadro number. The Avogadro number is 6.02 into 10 raised to power 23. If we divide these two relations, we will get another constant which is called K, Boltzmann constant, 1.38 into 10 raised to power minus 23. And units will be equal to joule per Kelvin. Here R divided by Na, as we discussed here, the R divided by Na is equal to K. Then the PV, the product of pressure and volume, is equal to NKT, which is another ideal gas equation. This ideal gas equation is in number of moles, but this ideal gas equation PV is equal to NKT in number of molecules. Let's say it's our second equation. If we equate both equation, PV is equal to 2N divided by 3 average kinetic energy from the pressure of a gas, and the PV, the product PV, is equal to NKT from ideal gas equation, then we will get another equation which is 2N divided by 3, the average kinetic energy, is equal to NKT from second equation. The capital N from the both sides will be cancelled out the number of molecules. We will left with the average kinetic energy is equal to 3 by 2. This 3 and 2 will be multiplied the other side of the equation, and we will get 3 by 2 into kT. In this equation, the average kinetic energy is equal to 3 by 2 kT. The term 3 determines the degrees of freedom. Degrees of freedom means as the molecules can go in x direction, y direction, and z direction, the translational motion in three directions, then its degree of freedom is 3. If the molecules can vibrate and rotate, then its degrees of freedom will be the 4 and 5. Here we are considering the only translational kinetic energy of these molecules. Hence, we get the average kinetic energy is equal to just 3 by 2 of kT. And if we consider the rotational motion and then vibrational motion, then its average kinetic energy will increase. As it is called the equipartition theorem. The equipartition theorem tells us that the average kinetic energy of each degree of freedom contribute to 1 by 2 of kT, the half kT. This energy contribute to the each degree of freedom. If the degree of freedom is just 1, then we will get 1 by 2 kT, and if degree of freedom is 2, then 2 by 2, just 2 by 2 cancel out, then average kinetic energy will be equal to just kT. And if the degree of freedom, as here the molecules in this container, the molecules can move in x direction, y direction, and z direction without vibration and rotation, then its degree of freedom is just 3, and we will get the average kinetic energy is equal to 3 by 2 of kT. Thanks for watching.